Okay, this is step 3 in the assembly process for the Halloween Skulls animatronic skull. And you're going to need several things here. As we mentioned at the end of part 1, you're going to need the HS77B, 2 HS225Bs. You'll need 2 of the gears that are labeled in there, the 24-tooth gears. You're going to need these 3 parts, the bottom 3-axis plate, we call that. This is the middle 3-axis plate, and this is the top 3-axis plate. And they all assemble in this manner. And they have to be able to move freely in their direction to make sure that that happens. And that there's no... we are going to put some grease in that. That's why I have this here, to get some put some grease in these grooves. It just makes it move smoother, and if it gets hot or anything in there, then the plastic parts won't bind and stick. Also, you're going to need this very tiny plastic piece. This is an insert that goes into the rotate servo coupler, which is right there. This you get from Servo City. It's in the parts list. So are the gears. They come from Servo City. You're going to need two of these washers. They come with the gears when you get them, so you'll have those. I need 2 sets of 4, so 8 total 632 1/4 inch screws, and also 4 632 1/2 inch screws. And that's what you're going to need. Oh, and this small metal piece, which is the square rods that you get from Vex Robotics. I have started to send these along because it's really hard for people sometimes to get them cut to the exact proper length, and if you get them cut to the wrong length, it can cause problems later on. So I have it's in the parts list where you can buy these rods, and then you have to cut them to this length, which I believe is either 19 or 20 millimeters. We'll have to check the parts list on it. You certainly can still do that, but any ones that I'm making now, I am sending out with that piece just to make sure that it all fits properly when you get it. So to begin, first thing we're going to do is set these parts aside for a moment and set up our servos. So we want to toss out the box and the extra parts that we don't need, or save them if you are so inclined. Get your two 225s out, and one 77BB. This is a specialty servo. It's called a low profile servo. It doesn't stick up as high as the others, and that is just because it also has a lot more torque than the other ones. And that's for the nod servo inside the head. And it has to be this low profile just because of how much space is inside the skull, and when it moves around, it hits. We actually put it on an angle, mounted it on an angle, because to get the most motion we can get without having the servo hit the sides. But for now, we're going to go back to our little Phillips head screwdriver, and we are going to take out all of the servo horns that are on these servos, and of course save the servo screws. There's one. I find that the screwdriver makes a nice pry bar to get the servo horns off very easily. Now, the one thing I didn't mention that we will definitely need in this part is the card, the controller card. And in order to get that controller card right, we're also going to have to do the wiring. We're going to do another section that says how to wire this up. And we have the wire. I've got to measure it out. We usually use 6-foot lengths of the power wire and 6-foot lengths for the input and output of the DMX. So I don't show that on the table right now, but you'll see it inserted into this video when the time comes. So right now what I'm going to do is I'm going to place the gears on the 2 servos that need it. That will be one of the 225s. There's that one. And in this case, we are going to screw it down right now. So we're going to put the washer on it. Right there. I'm going to put the screw in. Get it started. There we go. And now thread it down with the Phillips head screwdriver. And I usually let it turn the servo all the way to one direction and then give it one good tighten. Not so much that you break the servo, but enough that we don't want that to come loose in play. All right, that one's done. And the other servo gear goes on the 77 BB. The servos do have to start at their center positions in order to be assembled, and that's why we need the controller card hooked up so that we can turn it on and power up the servos so that they all reach their center positions for alignment, so that we know that when we put it in the skull, it will be looking straight forward and halfway up when it starts. Now we use the remaining pieces to put together the rotate servo. This is the one that will be flipped upside down on the top of the servo rack for the 3-axis motion. And for that, we're going to need to put in this coupler and also the rest of these parts here. So I'm going to put the coupler in. Doesn't matter which direction it's in. It does have, I don't know if you can see it, but it does have the little teeth on the inside that's made up with these servo teeth. There it goes. That fits down. Now we take the screw and drop that right down in the middle there. And with our screwdriver, we screw that down. And that makes sure that this does not come loose. And that goes all the way down. And again, I'm going to bring it to the end and turn it a little bit. Now, you will see there's a set screw on the end of that right there. We're going to put the little U-shaped cutout. This is basically so we can put a square peg in a round hole. We have to make the round hole a square hole. So I made this adapter with the 3D print. We throw that in there. And if you can see that, it's hard to see with that light. Let's see, maybe here. You can see there's the set screw. And that's the set screw is facing the open part of the square. Because that's going to go down and press down on this shaft. Now, when you get these shafts, one side is going to be cut, and I do my best to smooth it down and make it slick. But the machine cut one that it comes with on the top is the smoothest end, and that should be the one that sticks out. The rougher end is the one that's going to go in, and it pushes down into there and push it down as far as it goes. And tap it down with a screwdriver to make sure it's all the way down. Then you're going to get out your Allen wrench, and we're going to tighten that set screw down. There we go. And this has got to be pretty tight. You got to really torque this down as much as you can. You might, there we go. You might even want to put some Loctite on it and make sure it doesn't back off. But then if you do have to, it makes it more difficult to service later if you ever need to take this out. So I'm just going to really jam it down in there, and I'm going to leave that like that. Now, one more thing to do before we actually assemble this, because again, the servos have to be in their center positions in order to put them in here. But I'm going to grease all the rails. So I've got some just general purpose grease here. Multi-purpose synthetic grease. You can use almost anything. And I've got a little supply of toothpicks that I put inside the container here. So I can grab up a little bit of this grease. And basically you just lay it into the grooves. And it does make the thing move very smoothly. It gives it a little bit more resistance to move, but the motion is very smooth. So this one has only one groove in it. Well, no, it has two grooves in it, but they're different. So I'm going to put the grease in there and some grease on this side. And this one also, this one is different because it has a side bar. And that helps to keep the small piece aligned as it slides back and forth, because there's not much distance and these are short. So that keeps it going in a straight direction. And that's all you need there. Excuse me. Now to align these up, put them in place, you're going to put this one, which is the middle plate, on top of the bottom plate. and we'll slide it right through. You're going to get a buildup of grease on the ends here. You can just take those off and either place them back on the back side here. You can get it on the face of this too. They don't actually touch. There's a little bit of a gap there, and that's obviously on purpose. What you can see better here, probably this little gap there. So the only part that touches is these small rails. And so maybe if you had a little extra grease and you rubbed it on those rails, that'd be a good thing to do. So you can do that with the grease that comes off of here. Rub it right on the bottom rails. That's so that there's the least amount of friction that you can get, and that yet there's still control over this piece. Now that's moving nice and smoothly. Okay, then I'm going to take the top piece and I'm going to slide it in here, do the same thing. Now this one, the grease comes out. It doesn't come all the way out the back, it stops, but that's okay. So I'm going to grease the bottom of the sliders again, and then put them in. And now we've got a nice smooth sliding top piece. That's all the grease that we need for this step. We'll need this again. We'll need the grease again when we do the eye servos. But for now, that's all we need. So first thing that we have to do is to power up this board and power up the servos. So we're going to plug the servos in where they belong. I'm going to get this skull back on here from the first section. I'm not going to worry about the jaw servo quite yet, but we're going to do the rest. So if you're looking at the chart of how to wire up the controller board, you'll see that the bottom, what's labeled as the bottom, is this row here. So this is output number 1, 2, 3, and so on up to 12. So output 1 is the jaw, so I'm going to ignore that right now. Output 2 is the rotate servo. This is the rotate servo. It's the one with the square rod on it, which, of course, fits into the universal joint inside the skull. Like so. There it is. And then as the servo turns, it turns the skull. Okay, we're going to plug this into number 2. And when the board is in this configuration, the yellow wire is up. That's the signal wire. It's the top connector here. So you have to plug them in correctly. You also have to be very sure that you have your polarity correct here. And when you're plugging into the power supply, you have to make sure you see the red wire going into the positive and the black wire going into the negative. If you do that wrong, you can instantly burn up this card. You don't want to do that. Positive is here, negative is there. And on the power supply, it's etched into the little silver bar on the top. I have used Sharpie markers, a red one and a black one, and made a spot over which one so that if you can't really see the etched in part very well, you know that this one is the negative one and the one on the end is the positive one on the power supplies that we use. If you're using your own power supply, you got to see what that one has to show you, because they're all a little bit different. Okay, so the order goes the jaw servo first, which we're ignoring, the rotate servo, then the nod servo, then the tilt servo. So this is the nod servo, the heavy-duty low-profile one. That goes right after the rotate. We'll plug that in. Again, the yellow wire facing up. We'll get these screws out of the way a little bit. And then your tilt servo. Same thing. Screws right up. Okay, the next 2 connectors, this one and this one, connectors 5 and 6, are for the eyes left and right and eyes up and down. And so we use only the first 6 on here, but these servo boards have 12 outputs. The other outputs could be used for other props. You can run a servo extension right out of the skull down through the jaw and through the neck piece. And you can add a moving arm or any other prop that you want synchronized with it. So that's there are extra servo outputs for future expansion and for that. But for our purposes of just wiring up the skull, we're only going to use the first 6. And we've got 3 of them right here. So now we're going to power up the controller board. And I'm going to take one last look underneath it and make sure there is nothing at all that can short anything out underneath where that is before I apply power. I'm going to lift up this little shield here. We're going to take the black wire, of course, and plug it to the power. Now, another important thing about hooking up the power to it is right now this power supply is off. And when you're connecting your connectors, whether they be bare wires or fork terminals, it should always be off, the power supply. And the reason is, when you're connecting it, there's going to be points where you're just touching it and it's not tight yet, and that's going to be like a million little instantaneous connections to the board, powering it up, powering it down, powering it up, and that, in rapid succession, turning it on and off like that, can confuse the CPU on the board or the program chip, and it won't break the board, but it will break the programming, and it would have to be reprogrammed. And so we don't want to do that. So make your connections, make sure they're tight and secure on both ends, and then turn on your power supply. And you'll see the little green light there come on. Now we're powered up. My servos are powered up, and they have all centered. Okay. So they were pretty much in the center to begin with, so you didn't really see a big move, but I can show you on one of them that when I'll power that off, I'll wait for it to power down. Now I'll take this servo here, make a little mark on it so you can see where it is, and now I'm going to turn it so it's way off. Now when I turn on the power supply again, you'll see that it's going to center itself. And there you go. So that's why we have to do this. Now, there's a hole in all three of these boards. On the bottom one, you can see it right there. On the middle one, it's right here. And on the top one, it's right there. That is our alignment tool. I stick a small screwdriver through here. You can use a paper clip. You can use anything that's small and thin, go through a piece of thick wire. And that positions all the boards so that when the servos are in their center position and they're mounted in the board and the boards are in this position, then the skull is looking straight forward and centered. And that is very important, especially if you're going to ever be trading programs between different skulls. Like if you have a skull and you want to use a routine on it, the servo settings will all be exactly the same for that skull as they are for any other Halloween skull, because they're all aligned at the very beginning. So when we put on this servo, we're going to leave something in place so that the boards don't move. And this one screws up from the bottom, and the gear is on the side where you see it right now, opposite where the other servo goes for the tilt. And so I'm going to push this down. It's a little hard to screw it in there with this other screwdriver in place, but we'll make do. So I'm going to take this small 1/4 inch. We use all stainless steel screws so that even if they're in a moist environment, they will not rust. But because of that, they are non-magnetic. So you can't hold them in the end of your screwdriver and then put them in place. All right, so there's one is in. Never over tighten anything. You will strip out the threads. This is only plastic that it's being threaded into. I thread it down until it stops moving, and then just a tiny bit more, a 1/16 of a turn or less, just to make sure that they're snug and not going to slip out. But that's it. Okay, so that's the first one in its place. And that maintains that when the servo's in its center position, this is also centered. And that's exactly what you want. Now the second one is the nod servo. And the gear goes towards the back. This is the back side that goes into the back side of the skull. And the flat edge, as I mentioned before, is the front. This has some little notches here and here that match the notches in the servo there and there. So I'm going to turn it around this way, fit it in, and there it is. It's secure right in there. Now I'm going to take the 1/2 inch 632 screws, Okay, now the last one is going to be the top, the rotate servo. And that one, this part towards the front. And you notice it comes very, very close, almost hitting, possibly even resting against this servo. So another thing that I do with that when I'm doing it is I get a little bit more grease and just put it on the side of the servo. That way, if it does brush against this other servo, it's like less than 1 millimeter apart from it. Probably a 0.5 millimeter apart. But if it does bump up against it, it'll reduce the friction down to practically nothing, and it won't have an effect. So I'm doing that. I'm going to screw these in again using the 1/4 inch 632 screws. All right. Now I'm going to unplug this particular one here. This is the nod servo. And I usually take that wire and I stick it right in between these two servos so it comes out the front like that. I'm going to plug it back in. Now you may have noticed that when you power this up, you can hear the servos holding their position, and it lasts about 30 seconds and then it stops. And that is a feature programmed into the controller board. And what that does is gives you extra life on your servos. So if it's not being sent a DMX command for more than 30 seconds, the board remains powered, but it powers down the servos. And it waits for a command. And as soon as the command is given, it starts moving the servos again. Within a routine that you're playing, it's likely that you will... I can't think of any occasion where you would have more than 30 seconds with nothing happening to any servo. So that usually doesn't happen. But if you leave the power supply on and you walk away for 6 hours, your servos aren't sitting there holding position and adding to their early demise. They've got such a certain amount of time as a lifetime, and then they're out of it. So that's what's happening there. They turn off. I am going to, I'll move the nod servo. So you can see what that's doing is moving back and forth this servo, which causes the middle servo to move forward and backwards against the skull. Okay, now I'm going to move the tilt servo, which is the one in the back. And that slides this back and forth. It's going to make the skull tilt. Slow or fast. All right, and then I'll turn, if you can see it move. You should see this rod spin when I do the rotate servo. So everything's working fine, and it's ready to reset the positions to center. There we go. And now I'm going to put it in the skull. That will be the end of the assembly part for 3-axis plate, the 3-axis movement of the skull. Now you don't need any tools to put it in. I have already turned off the power supply, and now I'm going to disconnect it. Same rule applies for disconnecting power as connecting power. As you loosen the screw, it would make rapid connections. So you want to make sure the power supply is off. You see that the green light is off there. Before hooking up or disconnecting the power wires to the servo. So for the moment, this is just going to sit around here, and you'll notice inside the skull there are these 2 ridges, which forms a slot, and then you see the one here and the one here. And if it's better to see it in this light, you got a slot here and a slot there, and then you've got this slot in the middle. That's where this piece goes. Okay, so we're ready to insert the 3-axis mechanism into the skull. And as we pointed out earlier, you can see the slot in the back there that it slides into. That holds it from moving up and down. And also the 2 slots on the sides. And that's right where it's going to go. Now, one of the things that we're going to do is in the universal joint, we're going to get our grease out again, and we're going to just put a dab of it right in the top. That's it. And now that will help the square rod in the center of the rotate servo to slide smoothly in and out of that and not ever catch on the edge. That's this rod right here. And that's what holds the whole skull together, really. It's right on that one point. So as we set this up, it goes in this direction so that the tilt servo here is at the back of the skull, and the two wires for the top ones come out the front here. And you can see this pointing down, the square rod pointing down. And I'm going to start by just tilting it in here. I hope you can see this well. I'm going to put this wire around the other side, and you see this side is already in the slot, and it's headed towards the rest of them. And what we want to do is just get this so that that center rod slides in, and then we turn it like that. And that's it. Okay, so now the final step in this section is to first hook up the jaw servo. We're going to do that right now. This is the wire that goes to the jaw servo right here. And it goes in the same manner as all the others with the yellow wire on top. Plug that into the first pin, pin 1 from the bottom. And I'm going to just slide all of these things here underneath so they're not in the way. And that way the jaw can then move around. And now we're going to turn on the power. Power it up, show you the different motions that it has. You'll notice that this can slide in and out a little bit, which makes it not as accurate in turning. But all of that stops when you put the front on, because it has these areas here, which when it's screwed together, holds this into place. So once you put the front on, that can't move. But you will see it move a little bit now when we test it out. So I'm going to turn on the power. It jumped up. The jaw went to its closed position. Doesn't look closed because the head's not on it, but when it is, it would look very similar to that. So let's move it around and see if it works. First, we'll open the jaw a little bit. There you go. Close the jaw. Open, close. So we can do that. That's good. Let's bring it back down. We can nod the head, so it can go up and down and up and down. You can see not only the head moving, but you can see the servo action inside, moving it around. And as I said, this will wander a little bit until the front's put on. Now let's do the rotate. So this will be turning the head from one direction to the other. All right, and finally the tilt operation right here. And we mentioned earlier on about why this servo is tilted and why I had to get a low profile servo in there. And you can see, maybe you can't, but way down in the back, it is just about hitting the side of the skull, as the skull is gives you less room as it gets towards the back. So it can't go any further really without touching. And that's what determines the maximum length. However, because we managed to put it on an angle, we can move as far as the rod end allows us to in that direction, which is where it is now. So that was just a point of interest from an earlier comment that I made. Now we'll put that back, and there you have it. That ends this section of the Halloween Skulls animatronic skull tutorial, and we'll see you at the next one.